welcome back to our grade 10 maths lessons. I am Miss Awinu. In our last lesson, we looked at deductive reasoning and circle geometry, okay? How to find the size of angles simply using logical reasoning, okay? In today's lesson, we are going to look at applying algebra, okay? Applying algebra with circle geometry, okay? Algebra with circle geometry. Okay. Now, we already reviewed our properties in the last lesson, so I hope you still remember the properties of circles in terms of the chord, the tangent, and the chord and tangent together. Okay, so we're going to use an example to see how we apply algebra together with the circle properties. Okay, so let me just draw our circle first. Okay, so we have this angle here, 10x minus 4 degrees. And this angle is 8x plus 4 degrees. Okay, now how do we find the size of these angles here? Remember, we need to recall the properties and apply them correctly here so that we can find the value of this angle and this angle. Now, what do we know about the circle? Here we have the radius, okay, from the center of the circle, and it meets this tangent here at the circumference. So we know that this is going to create a right angle. Okay, we put that in. Now we can see that this is a right angle triangle, okay, with two angles represented by algebraic expressions. Now we need to find the value of both these angles. So in order to do that, we are going to apply the angle sum of the triangle, okay? Now we've already used the circle property to identify this angle. So now we use the angle sum of a triangle, which is 180 degrees. So 180 degrees is equal to, we have 90 degrees plus 10x minus 4 plus 8x plus 4. Okay. Now, once we have formed an equation, we are going to solve this equation using the skills we've already learned in previous lessons. Okay, so 180 is equal to 90. We have to collect our like terms. So 10x plus 8x will give us 18x. Okay, and negative 4 plus positive 4 is going to cancel out and give us 0, so we don't need to write that here. In order to find 18x, we have to bring 90 across. So 180 minus 90 is equal to 18x. 180 minus 90 will leave us with 90 degrees, okay, equal to 18x. We are going to find the value of x, so we divide by 18. Okay, so 90 divided by 18 is equal to x. And x is therefore equal to 5. Now, 5 is not the value of the angle. 5 represents x, all right? That's the value of x. In order to find the angle, we have to substitute 5 into these expressions, and then we find the angle, okay? So we're going to do that. The first angle is 10x minus 4, okay? So 10 multiplied by, in place of x, write 5, minus 4. So 10x, or 10 times 5 is 50, minus 4 will give us 46. So that's the value of this angle. Okay, now we find the second angle, 8x plus 4. Okay, 8 times 5 plus 4. 5 eighths are 40 plus 4 will give us 44 degrees. So this angle here is equal to 44 degrees. And this angle here is equal to 46 degrees. Okay, we check by adding the three angles here to see if we get the angle sum of 180. So 44 plus 46 is 90, and 90 plus that 90 there will give us 180. Okay, so we have used the second property together with algebra to find the size of the two missing angles here. Okay, now we're going to use one more example and see how we can apply algebra once again with second properties. All right, so example number 2, I'll have to put up the diagram first. So the angle here is equal to 7a minus 11, and the angle at the circumference is 3a plus 4. Okay, now just by looking at the diagram, we should already know what property we are going to use. Okay, now the angle at the circumference here is half of this angle at the center. Or we can say the angle at the center is twice the angle at the circumference. Now, how do we write that as when we are forming the equation? Okay, so 2 times this angle will give us this angle. So you write that out. 2 times this angle, 3a plus 4, is going to give us the value of the angle at the center. Okay, so we have written an equation using these expressions here by using the property. Okay, the property which states that the angle at the circumference is half this angle, we have simply rewritten that as an algebraic equation using the angles given. Okay, so we need to remove these brackets here so that we can work the value of a. So 2 times 3a will give us 6a plus 8 equal to 7a minus 11. Okay, now we have pronumerals on both sides, so we need to collect our like terms. And because we are moving them over the equal sign, they become their opposite. So 6a will come over to 7a, the one talk here, and negative 11 will go across to this side. Keep in mind, when they go over the equal sign, they become their opposite. Okay, so 7a remains. Positive 6 will come across this side and become 6a minus 6a. All right, 8 will stay here. Negative 11 will move across the equal sign and become its opposite. So we add 11. Right, that's the easiest way to do this. So 7a minus 6a will leave us with a. 8 plus 11 is 19. Again, 19 is not the value of the angle. We need to substitute 19 here so that we find the angle at the circumference and at the center. Okay, so let's see, 3a plus 4. Let's substitute. 3 times a is 19. Okay, plus 4. 3 times 19 plus 4 will give us a value of 61 degrees. Okay, so that's the angle here at the circumference. Now, we already know that the angle here is supposed to be double this number, But let's see if 19 substituted into this expression will give us twice 61. Okay, so 7a minus 11 is equal to 7 times 19 minus 11, which will give us a value of 122 degrees. Okay? In our next lesson, we will look at polynomials. What are polynomials? Join me in our next lesson to find out.